All right, so now what I need to do is, again, add those four bonds. Everything is going to be bonded to the central atom, and I'm going to represent those bonds with these lines. And a line, remember, is a bond which represents two electrons. So I'm going to put a bond between carbon and hydrogen here. Okay. I'm going to put a bond between carbon and hydrogen here. I'm going to put a bond between carbon and hydrogen up here. And I'm going to put a bond between carbon and hydrogen right here. Okay? So this is my molecule. I have four bonds. Now, do I need to add any lone pair electrons? No, because my math told me I didn't. The last step would be to add lone pair electrons. If I look up at step 7, it says arrange your lone pair electrons so that everything satisfies the octet rule. Everything wants 8 except hydrogen, which only wants 2. So I'm going to arrange leftover electrons so that everything has 8. But in this case, I have 0 lone pair electrons to add, so I don't need to add any more electrons. I'm just going to make sure everything has 8, except hydrogen, which only has 2. So this hydrogen has 2. It's happy because a bond is 2. This hydrogen has 2. It's happy because a bond is 2. This hydrogen has 2. It's happy because a bond is 2. And this hydrogen has 2. It's happy because a bond is 2. If I look at carbon, carbon needs 8. Each bond is 2. 2, 4, 6, 8. It's happy. So this is my Lewis dot structure for CH4. I'm done. I'm going to go on to the next problem. CCl4. And I'm going to do the same 7 steps to draw my Lewis dot structure. I'm going to start with my have section. Okay. I list my elements in my compound. I have carbon and I have chlorine. How many valence electrons does carbon have? Or excuse me, how many carbons do I have? 1. How many chlorines do I have? 4. Okay. I first list how many of each element I have. Now, how many valence electrons does carbon have? I check my periodic table. 4. How many valence electrons does chlorine have? I check my periodic table. 7. 1 times 4 is 4. 4 times 7 is 28. I add these up. 4 plus 28 is 32. So my have is 32. My have is 32. Okay, that's step 1. Then I go to step 2. Step 2 is need. I do the same thing. I list my elements and how many of each there are. I have 1 carbon. I have 4 chlorines. Okay? And then I list how many of each of these elements, or how many valence electrons each of these elements needs. Remembering, every element needs 8, except hydrogen, which only needs 2. So you're going to see a lot of 8s here. It's always going to be 8, except for hydrogen, like we see above, which is 2. So 1 times 8 is 8. 4 times 8 is 32. So now I add these up to get my sum of how many electrons I need. 8 plus 32 is 40. Here's my have, here's my need. Next step, need minus have. 40 minus 32 gives me 8 bonding electrons, and that is step 3. Step 4, take your bonding electrons and divide by 2. Step 4, take your bonding electrons and divide by 2. Now this tells me how many bonds I have. So in this case, 8 divided by 2 is 4 bonds. And that's an important piece of information that I like to highlight. I'm going to bold it here, but on yours, if you want to circle it, that's what I recommend. Okay? That's an important piece of information that's going to allow me to draw my Lewis dot structure. Step 5 of my math, the last step, is I take step 1. Step 1 was 32. Minus step 3, your bonding electrons, which is 8. 32 minus 8 gives you how many leftover electrons you have. 32 minus 8, 24 lone pair electrons, leftover electrons. Okay, 24 lone pair electrons. Again, that's an important piece of information. I'm going to circle it or bold it, whatever you want to do, so that you remember that's going to help me draw my structure. All right, I'm ready to draw. To draw, your least electronegative element goes in the middle. The element farthest away from fluorine would go in the middle. So if I look at my periodic table, my choices are carbon and chlorine. Who's farther away from fluorine? Hopefully your answer is carbon. Carbon is going to go in the middle. Next, I surround carbon with my 4 chlorines. So I have 1 chlorine on the left. I have 1 chlorine on the right. I have a chlorine above. And I have a chlorine below. So I've written my elements so that some elements are surrounding, the other elements are surrounding my central element. And now I'm ready to add my bonds. Remember, everything is going to be bonded to my central atom. So I'm going to have 4 bonds, and it just so happens that I have 4 elements to add those bonds to. So this first bond is going to go between a carbon and a chlorine. Okay? And I know it's not perfectly even, but hopefully you can remember that it's between that carbon and chlorine. I'm going to add another bond between this carbon and chlorine. So this is between the carbon and chlorine. And I'm going to add another bond between another carbon and chlorine. And that's going to go right here. Okay? And I'm going to add my last bond between my last carbon and chlorine, which is going to go right there. So I have 4 bonds between my carbon and my chlorines. Okay? Next, I'm going to add my lone pair electrons. Now in this case, it's not 0. So I need to add dots. Okay? 24. These dots go on whatever element still needs electrons. Okay? Now, carbon in the middle right now has 8. It doesn't need any more. But if I look at chlorine, chlorine only has 2 because a bond is 2 electrons. So, how many more dots do I need to add to chlorine? Hopefully your answer was 6. Okay? I need to add 6 dots to chlorine. Okay? So I'm going to go ahead and do that. I'm going to put dot here. Another dot here. Okay. Oops. Okay. Another dot here. Another dot here. And I'm going to continue adding those dots until I've added 6 dots to each chlorine. So as you can see here, here's my final Lewis dot structure of carbon tetrachloride, where each element has a full octet. Chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. And this carbon has 2, 4, 6, 8. Do I have 4 bonds? Yes. Do I have 24 lone pair or 24 dots? Yes. That's my Lewis dot structure for CCl4. All right. Let's do one more together. I have my halves. Okay. I list my elements. H, C, and N. Okay. I have one hydrogen, one carbon, and one nitrogen. How many valence electrons does hydrogen have on my periodic table? 1. How many does carbon have? 4. How many does nitrogen have? 5. 1 times 4 is 1. Or 1 times 1 is 1, sorry. 1 times 4 is 4. And 1 times 5 is 5. I add these up. 1 plus 4 plus 5 is 10. So my have, step 1, is 10. Okay? There's step 1. I go on to step 2. And this is going to get faster and hopefully easier for you. Step 2 is my need. I again list my elements. Hydrogen, I have 1. Carbon, I have 1. And nitrogen, I have 1. Okay. How many does every element need? Hopefully you're thinking 8, except hydrogen, which only needs 2. 1 times 2, I'm going to put this right away, is 2. Carbon needs 8. 1 times 8 is 8. And nitrogen needs 8, is 8. Okay? 2 plus 8 plus 8 is 18. So there is my need. Step 2. I'm ready for step 3. Need minus have. 18 minus 10 equals 8 bonding electrons. Okay. I take that number and divide it by 2 to get my number of bonds. So I take 8 divided by 2 to get my number of bonds, and that is 4 bonds. I like to highlight, circle, do whatever you need to do so that you remember that piece of information is important and helps you to draw your Lewis dot structure. Last mathematical step, step 1, 10, minus step 3, 8, gives me 2 lone pair electrons, leftover electrons. And with these 2 pieces of information, I'm ready to draw my molecule. So, in this case, my least electronegative element goes in the middle, excluding hydrogen. So it's either going to be carbon or nitrogen. It just so happens to be carbon. And as you can see here, it says carbon goes in the middle. So I have H, I have C, and I have N. Okay? Every atom is going to be bonded to that central atom. So, right away, I'm going to add bonds between the carbon and the hydrogen, and between the carbon and the nitrogen. So here I've added my 2 bonds. Okay? Now, I need to add 2 more bonds. Well, where's the only place those other 2 bonds can go? It has to go between 2 elements. So, the only place it can go is here. Okay? And here. Okay? So here I have 3 bonds between the carbon and the nitrogen. That's called a triple bond. Okay? Why is this the only place it can go? Because hydrogen only needs 2 electrons. So hydrogen cannot form more than 1 bond. Now I still have 2 lone pair electrons to place. Where are those 2 dots going to go? They're going to go here on the nitrogen. So I'm going to add 2 dots on my nitrogen to give that an octet. So I've added my 2 dots to nitrogen, and now this is my Lewis dot structure for HCN. H has a full octet with 2. Carbon has a full octet with 2, 4, 6, 8. Nitrogen has a full octet with 2, 4, 6, 8. Does my molecule have 4 bonds? Yes. Does it have 2 lone pair electrons? Yes. I'm done. So your homework is to finish these 4 Lewis dot structures for those molecules. The answer key is posted. Please check your work. Good luck. If you need to go rewatch these 2 videos, they are found on my website. Thank you.